and in this video we are going to discuss about the integration again, and this is our third or fourth video about the integrations, and then we have discussed some of the basic forms of integrations. Now we are just going step by step and trying to solve some special forms of integration. In the previous video you learned about how to find the integration of the terms like the tan square x and the cot square x just by converting them into the relation sec square x minus 1 cosec square x minus 1, and we found the integration. Now here we'll try to understand that how will you find the integration of sine cube x. And if you lack to understand something, then you just watch our previous videos and you can just simply connect with us and what exactly we are trying to teach. So here our case is that how to find the integration of sine cube x dx. You know that we do have only one formula that says integration of sine dx is minus cos x plus c. In this condition we do not have any direct formula which can help you to find the integration of sine cube x dx, but you have one relation which you have studied in the trigonometrical identities, which goes like this: sine 3x is 3 sine x minus 4 sine cube x. Now I try to make sine cube x as subject, so sine cube x will become 3 sine x minus sine 3x all divided by 4. So here in the place of the sine cube x we will put this term and we will integrate this term rather than integrating this term directly. So we have, first I'll try to write in the proper form. So 3 over 4 sine x dx. First let me write the one term, I should not be in hurry. And then sine 3x over 4, this is dx. So in this condition, now you take 3 by 4 outside from the first term, and then we have integration of sine x dx, sine x dx, and minus 1 by 4 and the integration of sine 3x dx, sine 3x dx. So I write the integration directly here. So this is 3 by 4. Integration of sine x dx is minus cos x, so you can write here minus cos x, and this is minus 1 over 4. Integration of sine 3x, that is treated as sine something rather than sine x, so integration of that one is minus cos 3x divided by differentiation of this, that is 3, and then you introduce the constant of integration there. So now you have minus 3 by 4 cos x plus 1 over 12 cos 3x plus c. This is your answer. So now I'll need to clear my screen and then I'll just tell you how to find the integration of cos cube x in just after some minute. So again in this case I'm taking the form of how to find the integration of cos cube x dx. Now you know that just like sine 3x, there is always a formula for cos 3x, and the formula goes like cos 3x is 4 cos cube x minus 3 cos x. In this time I'll try to make cos cube x as subject. So here this time it's become cos cube x, 4 times cos cube x is, this comes, I mean to say that this one remains here only, and I'm taking this one on this side, so better don't get confused. So write cos 3x plus 3 cos x all divided by 4 is cos cube x. So instead of integrating this term, I integrate this term. So now again here I write, so this is my term. So the first term is 1 over 4 cos 3x plus 3 over 4 cos x all dx. So I separate this sum of integration is integration of sum. So 1 by 4 integration of cos 3x dx plus 3 over 4 integration of cos x dx. You know this is a formula that integration of cos x dx is sine x plus c. So at the place of this I write 1 by 4, this is sine 3x over 3 plus 3 by 4 sine x, and then the next line I write 1 over 12 sine 3x plus 3 by 4 sine x plus c. This is the term which you get after integrating this term. So this is how you can find the integration of cos qx. As after cleaning the screen, I'll try to understand that how there are some other forms and how can you find the integration of those special forms. Just give me some time so that I can clear the screen and come back to you again. In the previous video you learned about how to find the integration of sine square x and cos square x, and then now in this time we'll try to understand how to find the integration of sine to the power 4x dx without using the idea of mathematical induction. We just go directly and then try to find using the plain trigonometrical identities find the integration of this term. How? So you know that cos 2x or cos 2 theta, I write theta better, cos 2 theta is 1 minus 2 sine square theta. So 2 sine square theta is 1 minus cos 2x over 2. This should be 2 and this should be sine square x. So now this one is not required. So sine square x, I take it on this side and then find sine square theta is 1 minus cos 2 theta. Changing the variable time and again we find is creating some complication. Now 1 minus cos 2 theta over 2. But we have sine square x. We don't have sine square this. Then what will I do? That how to find sine to the power 4x? I can write it as sine square x and whole square. So sine square x on the basis of this formula we can write as 1 minus cos 2x over 2 whole square, that is 1 over 2 minus cos 2x over 2 whole square. So if you expand this, then what you are going to get? So 1 by 2 square is 1 over 4 minus 2 times this into this is just cos 2x over 2 plus square of this, that is cos square 2x over 4, and this is dx. So now you see this one is integrable, this is integrable, this one is not. So how you can convert this one integration form? Because we know that cos 2x, is one more set of formula which says that cos 2 theta is 2 cos square theta minus 1. So cos 2 theta plus 1 over 2 is cos square theta. Now we have cos square 2x. So if I write, suppose here see if it is theta, then it has to be 2 theta. If I write 2 theta here, then this will become cos 4x. So I write, so this becomes cos 4x plus 1 over 2, and this is cos square 2x. So the cos square 2x can be written as 1 plus cos 4x over 2. So here I break this down as sum or difference of the integrals into the difference and sum of integrals. So this becomes integration 1 by 4, take it outside, 1 dx minus 1 by 2 outside integration of cos 2x dx plus 1 by 4 outside, and at the place of cos square 2x I am going to write as 1 plus cos 4x over 2. So this 2 is again coming outside, 1 over 2, and at the place of this I can write 1 plus cos 4x dx. So let me create a separator here. Now I find, so this is 1 by 4x minus 1 by 2. Integration of cos 2x will be sin 2x over 2. So this is sin 2x over 2 plus this is 1 by 8. There are two terms, one is 1, one is cos 4x. So integration of 1 is 1 by 8x plus integration of cos 4x will be sin 4x over 4, and along with this 1 by 8, so this will come 1 by 32 sin 4x, and this is my constant of integration. Now here see that I have 1 by 4x and 1 by 8x, so I can find these two. We need to just add them because these two are just like terms, so we need to write at one term only at this place. So 1 by 4 can be written as 2 by 8, and 2 by 8 plus 1 by 8 will be 3 by 8. So I remove this term from here, and then here I write just 3 by 8 or 3 over 8. So now 3 by 8 minus 1 by 2, and 1 by 2 should be written only as 1 by 4. So this one, so 3 by 8x minus sin 2x by 4 plus 1 over 32 sin 4x plus c. This is how you can find the integration of sin to the power 4x or sin to the power 6x, or cos to the power 4x and cos to the power 6x respectively. In this next very video, we are going to find out the integrations where the product of trigonometrical identities are given, how we can convert, because in those who have studied trigonometrical identity, they know that there are some ways by which we can convert the product of trigonometrical identities, the product into the sum and sum into the product. So using those ideas, we'll try to break down the product of two or more trigonometrical ratios into the sum or two or more trigonometrical ratios and try to integrate them one by one. So thank you very much. Keep watching our videos and keep practicing. Thank you very much.